Good afternoon, guys. Welcome to the 40th lecture of Environmental Engineering subject. Today we are on the Unit 4. Today we are in the Unit 4. We are discussing the third lecture in this Unit 4. So in the last class we have discussed about the introduction of aerobic and anaerobic treatment process in the secondary process. Today in this class we'll discuss about the comparison of aerobic and anaerobic process. So we will see what is the major comparison between the aerobic and anaerobic process in the secondary treatment process. Later we discuss about the suspended growth process, that the conventional activated sludge process, right? The conventional activated sludge process and the process, the designs, principle and operational problems. Later, some of the modifications in the activated sludge process and what are the types of oxidation ponds and aerated lagoons, right? Okay. So this is a picture which will be till your end of this unit. So we are at this point, this has been already completed. So in the secondary treatment plant, so here we are having the aeration tank. So here we can do aerobic process and anaerobic process, right? So after this process, through the pipe, the water is going to the secondary clarifier where you are having the activated sludge process, right? Again, here the water is going filtered and again it is going into the aeration tank. Again, it is passing into the secondary as a secondary effluent process. So like this, we are having the major concept in this secondary treatment process. Okay. Now, if you see the treatment process, so if you get any question like sketch and explain the water treatment process. So collection network. So every water is collecting at this point. So that is from a storm water, that is from other sludge treatment process, other from other various water. We are getting the water at this point. So from here, the pre-treatment works and storm workflow takes place. So it is going to the primary sedimentation, right? So from here, it is going to the biological treatment, that is a secondary treatment or clarification process. So here it is taking some of the material, some of the solid materials is passing into the, some of the solid materials are passing into the activated sludge treatment process. తినండి నాకు ఇంటర్నెట్ స్లో ఉంది మీరు తినండి sludge treatment process, right? So from here it is going to the sludge reusal and sludge disposal management. So here you see the darker line, check, hello, yes, you see the darker line here, it is so from the biological treatment process, it is going to the sedimentary settling or clarification. From here, it is going to the nutrient removal, where we are removing the nutrient, and finally we are going to the effluent, where the water is going to the effluent process, right? So from here, the final effluent means the treated wastewater, again it is coming into this chamber and finally it is going to the receiving streams where the water is received. Again, this water can be recirculated by this process and it is going into the same process, right? So here the dotted lines indicates the sludge, which is a solid material. The dark line indicates the wastewater processes described in this manner. Okay, so whatever the dark lines you are seeing, these are nothing but the wastewater. Whatever the dotted lines is nothing but the sludge, right? So in the primary sedimentation, you are getting the sludge going to the sludge treatment. In the secondary treatment, so you are going to the sludge treatment. In the nutrient removal also, the sludge is going to the treatment process. Here it is treated and it is reused or disposed outside. Okay. So again, this secondary treatment process. So the final effluent is going into the receiving stream, and here, if we want to go for recycling process, again we are going into this biological treatment process. In this biological treatment process, we are having anaerobic and aerobic treatment process. We are at this point, right? Next. So if you see the comparison between the aerobic process and anaerobic process, so if you get a question like distinguish between aerobic and anaerobic treatment process in the wastewater, so we have tried this type of concept. First one, the reactors. First one is the reactors. Aerated lagoons, oxidation ditches, stabilization ponds, trickling filters, and biological discs. So these are the reactors. Okay, these are the reactors in aerobic process. In this anaerobic process, you are having UASB. So this will be discussed with the trickling filters, UASB, lagoons will be discussed in the coming classes. But as per the topic, you are having this one in the first concept. UASB, anaerobic filter, upflow packed bed reactor, CSTR, downflow fixed film reactor, bioion filter, bioreactor. Next, coming to the reactor size, aerated lagoons, trickling filters, biological disc require larger land. So when coming to the size of the these reactors, we require larger area, but for the SBR needs comparatively low area, right? Coming to the anaerobic process, it requires smaller size is required. Okay. Next, third one. This is the second difference. Then the third difference is effluent quality. Means treated treated water యొక్క quality ఎలా ఉంటుంది. That means that is the effluent quality. Here, the excellent effluent quality in terms of COD and BOD. The aerobic process, because of the presence of oxygen, the effluent is excellent quality in terms of COD and BOD, and nutrient removal is achieved, right? But as in this anaerobic process, the effluent quality in terms of COD is normal, not excellent, just it is a good or fair. But further treatment is required for this anaerobic process. Effluent treatment alone in the condition, it further treatment is required for this process, and the nutrient removal is very poor in this anaerobic treatment process, right? Here the nutrient removal is good, but here the nutrient removal is bad. So this is a third factor. First factor which is the reactors. What are the various types of reactors used for the aerobic and anaerobic? Second one, the reactor size. So what is the size of the reactors? Here it is large, here it is a small. Next, effluent quality. So here we are having good effluent quality, whereas here normal effluent quality, and the nutrients removal is achieved, but here it is very poor. Next, fourth one is energy. Fourth one is a energy. Here, high energy is required. Okay, here high energy is required, but here this process produce energy in the form of methane. Okay, in the anaerobic process, because of the absence of oxygen, right, the energy produced is in the form of methane. But here the high energy is produced, but not in the form of methane. Next, biomass yield. Yield and the biomass. Whenever you are doing the aerobic process or anaerobic process, how much yield you are getting in comparison to the anaerobic process. In comparison to the anaerobic process, 6 to 8 times greater biomass is produced. Okay, in comparison to anaerobic process, 6 to 8 times greater biomass is produced. But here, lower biomass is produced. In anaerobic process, lower biomass is produced. Next, sixth one, loading rate. Maximum 9,000 grams COD per meter cube is reported in the literature. So the loading rate is maximum. Simply we can write the loading rate is maximum. Here very high loading rate of 31 kg COD per meter cube is reported. This is the reason for small reactor volume and lesser area. So here when compared to the loading rate, here you are having maximum, here you are having minimum, right? That's why here the size of the reactor is small, here the size of the reactor is large. Next, oil and grease removal. Seventh one is oil. Sorry, seventh one is the oil and grease removal. So here they do not cause serious problems. They do not cause serious problems in aerobic process. So the concept of oil and grease removal does not make any disturbances to the aerobic process. Example, Kumatsu. Kumatsu is a person, is an author for this topic, for this sentence. So there is no one. Next, fats in the wastewater shows the inhibitory action during anaerobic treatment of water. So here the oil and grease removal. Here there is no problem, but here there is a problem that the oil and grease in the form of fats, the wastewater shows the inhibitory action during the anaerobic treatment. During the anaerobic treatment, right? These are the various factors of aerobic process and anaerobic process. Next one. Next one is a aerobic other aerobic treatment units. So in the aerobic process, what are the other treatment units? So the other treatment units in the aerobic process is stabilization ponds. The stabilization ponds are open flow through basins specifically designed and constructed to treat sewage and biodegradable industrial waste. So what is the concept of stabilization ponds? It is an open type of flow where you are having the construction of basins is then in the open area, specially designed and constructed to treat what? To treat sewage and biodegradable industrial waste. They provide long detention periods. They provide long detention periods extending from a few to several days. They provide a long detention periods extending from few days to many days. Next unit in the aerated treatment is aerated lagoons. The pond system in which it is also some type of pond system in which the oxygen is provided through mechanical aeration. The oxygen is provided through some sort of mechanical devices, that is the pumps. Okay, through mechanical aeration rather than algal photosynthesis are called aerated lagoons. So in the aerated lagoons, what we are doing here, we are in the aerated lagoons. Here, oxygen is provided through mechanical aeration. How it is provided? Through mechanical aeration rather than normal photosynthesis process. Okay. Next, third one, oxidation ditch. Oxidation ditch. So what is the oxidation ditch here? The oxidation ditch is a modified form of extended aeration. So what is the meaning of oxidation ditch here? It is a modified form of extended aeration of activated sludge process. The ditch consists of ditch and just like a small hole on the land. The ditch consists of a long continuous channel, right? A ditch consists of a long continuous channel, oval in shape, oval in shape, oval in shape, with the two surfaces rotors placed across the channel. So I'll show the figure, don't worry. So the oxidation ditch is also another type of treatment process where it is modified form of extended aeration. It consists of a long channel which is oval in shape with two surface rotors placing across a channel. Next one. Anaerobic treatment. So what is the meaning of anaerobic treatment? In absence of oxygen, right? The anaerobic waste treatment process is an effective method for the treatment of many organic waste. So organic waste treat cheyadaniki anaerobic process is also one of the effective method. The treatment has number of advantages over aerobic treatment process. Then what are the advantages here? The advantages are the advantages are the various advantages are the energy input of the system is low. The energy input of the system is low as no energy is required for oxygenation, right? The energy input of the system is low as no energy is required for oxygenation. What is the second one? Lower production. Next one is lower production of excess sludge. Okay. The second one is lower production of excess sludge per unit mass of substrate utilized. Third one is lower nutrient requirement due to the lower biological synthesis. Fourth one is degradation leads to the production of biomass. So degradation of this material leads to the production of biomass, which is valuable source of energy. So these are the four advantages over aerobic treatment process, right? So here the lower nutrient requirement due to the lower biological synthesis. But whenever you are degrading these things, this biomass, whenever you are degrading this organic waste, it leads to the production of the biomass, which is very, very valuable energy for the other sources. Next one. Next, see how the sequential mechanism of an anaerobic waste treatment process goes. The sequential mechanism of anaerobic waste treatment. Here, the insoluble organs, right? The insoluble organs are converted into the soluble organs by extracellular enzymes. Later, this soluble organs are producing bacteria. Thereby, they are divided into three types. That is bacterial cells, that is volatile acids, and the other products. Right. Next, the volatile acid, that is carbon dioxide plus hydrogen, is added with the methane. Is added with the methane producing CH4 plus carbon dioxide. That is, you are getting methane and back carbon dioxide cells. That is a simple mechanism of anaerobic waste. So in anaerobic waste, you are producing methane, whereas in the aerobic waste, we are not producing methane. That is a simple diagram what it is showing. Next coming to the anaerobic reactor. The various types of anaerobic units have been developed in this secondary treatment process. So anaerobic treatment. So whenever you are getting a question like what are the various types of anaerobic reactors, these are the various types of anaerobic reactors, right? In that first one is upflow anaerobic filters. First one is a upflow anaerobic filters. So in the upflow anaerobic filters, packed with either pebbles, stones, PVC sheets, etc. So here what happens? You are having a container. In the container, the pebbles, aquariums lo veskuన్న pebbles, small stones, PVC sheets are arranged as a media to support the submerged biological growth. Okay, so these are used to support submerged biological growth. That is a fixed film. This form as a fixed film. The units are reported to the work, but the units are reported to work well, but like a problem is accumulation of solids in the interstices. Okay, the units are reported to the work well, but a likely problem is accumulation of solids in the interstices. Next one is downflow anaerobic filters. So in the upflow anaerobic filters, you are having this kind. Here it is packed with the similar media. Similar media means the pebble stones or PVC sheets above, but not to be confused with usual trickling filters, which is aerobic. In the anaerobic units, the inlet and outlet are so placed that the media and the fixed film stay submerged. Third one is UASB type units. Here, no special media. Media means this all the things. No special media have to be used since the sludge granules themselves act as a media and stay in suspension. These are commonly preferred. So in this UASB type, so whatever the tank in the sedimentation, the sludge activated sludge tank, so the water is staying at the top surface. Whatever the pebbles you are arranging in the upflow, aerobic and downflow. So here, this layer makes the sludge to accumulate in the small areas, Whereas in the UASB type, There are no separate pebbles like this. Okay, so directly the sludge granules themselves act as a media, and they stay in suspension and they collect the sludge. Next, fluidized bed units. These are filled with sand or plastic granules, or used with recirculation under the required pressure to keep the entire mass fluidized and the sludge distributed over the entire reactor volume. Here, the power consumption is higher. Why? Because we are using various things here. That's why the pressure power consumption is higher. So generally, what are this all these four types of reactors? These reactors are indented. These reactors are indented to collect the waste material, to collect the sludge material from the primary effluent wastewater, right? So here they are using different media. What are the media? The stones, pebbles, PVC sheets, right? So these are the various types of materials which are placed at the bottom bed of the container in order to collect the waste material. That is nothing but anaerobic reactors. Okay. Next, if you see the difference between the aerobic process, this is see here, this is aerobic and this is anaerobes. So in aerobics, the bacteria is introduced. In anaerobic also, the bacteria is introduced. Here, what are the inputs here? The organic contaminants, the oxygen, the nutrients. Okay, these three are the input for this bacteria. Then what is the output here? The water is output, the carbon dioxide is output, and the excess cell mass is the output. Okay, next. In this case, anaerobic process, what are the inputs? The organic contaminants, the nutrients, right? These are the inputs, but not the oxygen, because it is in absence of oxygen కాబట్టి oxygen అనేది మనం input ఇవ్వము. Then what are the outputs here? The outputs are, these are the outputs. What are the outputs here? The outputs are carbon dioxide and methane. Simple diagram, right? To understand the aerobic process and anaerobic process. So these both process should be done for the secondary treatment process, right? So here, these are the inputs. These are the inputs. Okay, these are the inputs for this anaerobic process. These are the output for aerobic process. Okay, don't get confused. Okay, the inputs and the outputs. Carbon dioxide and methane are the outputs. Here, carbon dioxide plus water are the outputs. Simple diagram, keep this in mind. So here, excess cell mass is coming outside. Here also excess cell mass is coming outside. Next, if you see the mechanism of oxidation pond, like when I check on oxidation pond mechanism, if you see here, here it is a cyclic process. It is a cyclic process under the photosynthesis, under the sun. Here the bacteria is oxidized, the organic cells. So the output is this one. With the photosynthesis, sun rays, with the outside atmosphere, algae is forming. Again, it is reduced into oxygen. Again, it is reduced into the bacteria. Just is a normal figure what I'm showing. Next, see where the aerobic and anaerobic treatment process are going on, right? So this is a primary treatment what we have already discussed. So there is nothing to discuss here. So see here, this is a secondary treatment process. Okay, this one is a third treatment process or advanced treatment process. Okay, so in the aerobic waste treatment process, whatever the whatever the water coming from the primary treatment, that is effluent primary water, is going into the aeration chamber. Is going into the aeration chamber. See here, aeration chamber. These are skimmed. These waters are skimmed. Thereby, the material, whatever the oxygen we are providing to this FBO, FBDs, right? These are process blowers. So here, with the motor, the oxygen is going inside this water. So in the activated sludge takes place, whatever the water is has to pass to the pipeline. It is passing into this clarifier or a sedimentation tank, and waste material is coming down, and again it is going to the same repetitive process. Okay. Next, after recycling, again the water goes from here to this process where you are adding some disinfectants. That is a chlorine disinfection. That is in this aerobic treatment process. If you see the anaerobic process, if you see the anaerobic system, anaerobic system, so the raw waste water, so it primarily అయిపోతుంది. So here the primary is completed. So here the water is going in the biomass and making the biomass process. Here the aeration tank. In this aeration tank, the air is passed in this aeration tank, right? Thereby whatever the sludge material is forming is settling at the bottom of the tank, and the water is going into the membrane tank. So in this membrane, you are having different filters. Thereby the filters will collect the waste material, and the water is going into the motor through the pump. It is passing into the effluent, means the treated wastewater is coming out of this effluent tank, right? The biomass is prepared in this tank. What are the results of this one? The methane and carbon dioxide, this anaerobic process. Next one, applications of the various ponds. So what are the types of ponds here? Aerobic pond, anaerobic pond, and facultative pond. So in the Aerobic pond, what is the application where you are using this Aerobic ponds? Treatment of soluble organic waste, treatment of soluble organic waste and effluents from waste water treatment plants. So these are used for treatment of soluble organic waste. Soluble organic waste key we are using for this one, and effluent from wastewater treatment. Coming to the anaerobic process, treatment of domestic and industrial waste. Okay, now, so anaerobic process where you are using anaerobic ponds, we are using in domestic and industrial applications, whereas aerobic process we are using in organic waste and effluent of the wastewater treatment plant. Next, third one, facultative treatment plant. The treatment of untreated screened wastewater. The facultative treatment is used for the application of treatment of untreated screened wastewater. What's the meaning of untreated screened wastewater? It is nothing but influent. It's nothing but influent. Okay, it's nothing but the influent process. Okay, understood? So this is the main concept of Aerobic process and anaerobic process, the definitions, the concept, the applications, and the comparison between aerobic and anaerobic based process. Okay. Next, we will see the next topic is suspended growth process. Okay, suspended growth process. In this suspended growth process, in the suspended growth process, okay, the suspended growth process, what are the topics to be discussed is, so we will discuss what is the meaning of activated sludge process in the secondary treatment. What is the concept of activated sludge process, right? How the conventional activated sludge process has been designed and operated, and what are the changes has been done for the latest versions of activated sludge process, and what are the principles and what are the design conditions. So this activated sludge process is done in the secondary treatment process, right? Activated sludge process. And the other topics, the modifications of the activated sludge process we will discuss, and the introduction to the oxidation ponds. So in the previous slide, I have given only the basic application and basic application of the oxygen pond. But here we'll go in details about the oxidation ponds. Next, what is the meaning of aerated lagoons, right? What is the meaning of the aerated lagoon? What are the types of aerated lagoons which are used in this wastewater treatment plant, right? So we will discuss these topics in the coming classes. Now, what is the meaning of activated sludge process? So this is the most common suspended growth. Suspended means you are suspending into the water, growth takes place. Okay, it is a common suspended growth process used for municipal wastewater treatment. Right, it is a most common suspended growth process used for municipal wastewater treatment is the activated sludge process. Okay, so which is shown in the figure, right? Then the activated sludge simply is calling is a sludge practices produced in wastewater by the growth of microorganisms in aeration tank. ఓకేనా సో ఈ యాక్టివేటెడ్ స్లడ్జ్ ప్రాసెస్ ఎలా చేస్తాము సో ఫర్ for the growth of microorganisms in aeration tank, both in aerobic process and anaerobic process. Okay, so it is a sludge. It is a activated sludge. Is sludge particles produced in the wastewater. Sludge particles primary treatment లో మనము సపరేట్ చేసిన తర్వాత బార్ ర్యాక్స్ నుంచి తర్వాత కంప్యూటర్స్ నుంచి the big large particles are removed, and whatever the small suspended particles which are mixed in the water, this sludge particles are produced in the wastewater. So these are removed by the growth of the microorganisms in the aeration tank. Aeration tank ekkada untundi? See the figure in any. So this is the aeration tank, right? This is a aeration tank, or here also you can see this aeration tank, right? Okay. So the activated sludge process is defined as a biological wastewater treatment process that uses microorganisms to feed an organic contaminant. Organic contaminant. So organic contaminants we are getting from the domestic applications, right? Domestic sewage water. So we are adding microorganisms into the organic contaminants in the wastewater to produce what? High quality effluent. So microorganisms ni we are feeding by taking this organic contaminants. సో మైక్రో ఆర్గానిజమ్స్ మనం లోపల డెవలప్ చేస్తే అవి ఎలా బతుకుతుంది, ఎలా ఫీడ్ అవుతాయి? బై దిస్ ఆర్గానిక్ కంటామినెంట్స్ ఇన్ ద వేస్ట్ వాటర్ టు ప్రొడ్యూస్ వాట్ దే ప్రొడ్యూస్ the wastewater. They produce high quality effluent. For reasonable operating and maintenance cost. For reasonable operating and maintenance cost. So this is simply meaning of the activated sludge process, right? So it's a produce of high quality effluent. Effluent means treated wastewater for the reasonable operating and maintenance cost. Okay. Next, if you see the flow chart or a flow sheet of an activated sludge system. So this is a primary. Leave this one, which is already discussed. It's already discussed in the unit 3. So unit 3 lo manam discuss chestunnam. So there is no need of drawing or discussing this one, right? So only see or draw this one. So whenever the effluent water, whenever the treated water is coming from the primary treatment process, it is going into the activated sludge or aeration tank. Activated sludge aeration tank. From here, it is going to the final settling. So here, whatever the suspended particles, sludge process, suspended sludge is settled at the bottom, is again coming into the down chamber through the pump. Again, it is settling to the sludge. Again, it is going into this process, right? So like this, the water is keep on making a circulations, and it is going into the final setting tank for the later. It is treated as a effluent. So whatever the sludge is coming is accumulated is coming down in the excess sludge, and through the digester it is going into the sludge drying compartment. So here what the solid sludge material is getting dried. Okay, so here the water is recirculating, and again it is filtering, again it is going as a effluent treated water. Okay, so here primary treatment lo effluent water దీనిలోకి వెళ్ళంగానే మళ్ళీ అది ఇన్ఫ్లుయెంట్ లాగా అయిపోయి again with this aeration tank they will further go for the treatment process, and finally effluent is coming outside. So here the sludge అనేది మనకి కిందకు వచ్చేస్తుంది through other chambers. It is coming to the the sludge drying chamber through the digester process. That is the simple flow diagram of the activated sludge system. So మీరు ఇంతవరకు వేసిన సరిపోతుంది, రైట్? అప్ టు సింపుల్ ఫిగర్, బాక్స్, ఐరేషన్ ట్యాంక్, ఒక క్లారిఫైయర్ ఆఫ్ ఫైనల్ సెటిలింగ్ ఆర్ సెడిమెంటేషన్ ట్యాంక్. ఇక్కడ నుంచి వాటర్ ఈజ్ గోయింగ్ అవుట్. కిందకి ఏం జరుగుతుంది, మళ్ళీ రివర్స్ తీసుకొని వాటర్ వెళ్తుంది. మీరు కిందకి ఒక ట్యాంక్ వేసి విల్ సింప్లీ సే దట్ ఈస్ ఏ sludge drying chamber. Next. Next one, the activated sludge plant. Generally, the activated sludge plant generally consists of what? See here, first one. The activated sludge plant generally consists of wastewater aeration in the presence of microbial suspension. So the plant consists of wastewater aeration tank in the presence of microbial suspension. Ante microorganisms suspend ayi unna aeration tank lo the wastewater is located. That is one part. It involves one wastewater aeration tank in the presence of microbial suspension. Second one, solid liquid separation following aeration. Second one involves solid liquid separation following the aeration process. Third one, discharge of clarifying effluent. See here, the discharge of, this is a clarifying effluent. Discharge, it is a settling tank అనొచ్చు, sedimentation అనొచ్చు, లేదంటే clarifier అన్న అనొచ్చు. Next, wastage of excess biomass, right? So with the wastage of excess biomass, it is coming downwards, right? Next, returning of the remaining biomass to the aeration tank. So here, returning of the sludge again to the aeration tank, again it is going. So like this, the waste material keep on coming, and finally whatever the total waste, whatever the unused waste is coming in the form of this sludge drying chamber. So these are the 5 things which where the activated sludge plant consists of. Okay, what is the first one? Wastewater aeration in the presence of microbial suspension. Second one, solid liquid separator following the aeration. Third one, discharge of clarified effluent. Fourth one, wastage of excess biomass. Fifth one, return of the biomass to the aeration tank. These are the 5 things which are involved in the activated sludge plant. So if you see the activated sludge process, in activated sludge process, the wastewater containing the organic matter is aerated. So ఎక్కడ జరుగుతుంది aeration process? Whatever the wastewater, ఈ పైప్ ఉంది కదా, ఈ పైప్ లోపల whatever the wastewater contains the this microorganisms is passed into this activated aeration tank, right? So is in the aeration, organic matter is aerated in the aeration basin in which the microorganisms metabolize unsuspended insoluble organic matter. Next point, the part of the organic matter is synthesized into the new cells and the part is oxidized carbon dioxide. ఈ reaction already we have done in the ముందు slides లో మనం చూసాం reaction. The new cells are formed and the part is oxidized to carbon dioxide and water to derive the energy. Next, in activated sludge systems, the new cells which are formed in the reaction are removed from the liquid stream in the form of flocculent sludge in the settling tanks. A part of this settled biomass described as activated sludge. So keep in mind, the settled biomass, sludge అంటున్నాం కదా, the settled biomass which is settled at the bottom. ఎక్కడ settled at the bottom. So here ఈ ఫిగర్ లో చూడండి సింప్లీ. So which is settled at the bottom of the biomass content or the sludge content, it is coming separately, right? A part of this settled biomass, described as activated sludge, is returned to the aeration tank and the remaining forms waste or excess sludge. Okay, a part of this settled biomass described. So, a part of this settled biomass, which is known as activated sludge, is returned again to the aeration tank and again is getting filtered and getting processed. And the remaining waste, which is coming, is nothing but the excess sludge that is happening in the tank, the aeration tank, right? Next. Next topic is activated sludge process variables. What are the various variables that are used whenever the activated sludge process is working? Okay, so I think the time is up. 9:27, 37, 47, 67, right? So we'll discuss the class in the next half. Okay, have a nice day. The link is the video is uploaded in the YouTube channel. Later, the link is forwarded to WhatsApp group and forward this link to other people, those who are not in this class. Right. So thanks for listening to the class. Have a great day.